In today's video, I have brought you a very nice equation from the Canadian Mathematical Olympiad, but I'm not sure which year this problem is. So anyway, here is the following statement. We have x squared plus x squared all over 1 plus x quadratic square, which equals 3. So our goal, we are going to solve this equation. They don't even tell us which set we can solve this equation. This equation is clearly not going to accept any solution in integer numbers. Let me know in the comment section below why this equation doesn't accept any solution in integer numbers. Okay, let's get into it to see what's going to be. Okay, so first of all, I'm going to check the dominator range of this equation. It's simply we have x must be different than minus number 1 because we have 1 plus x is situated in the denominator. Okay, now I'm going to apply a little trick here on the numerator on this one here. So I will have a following. I will have x squared. So this x squared becomes x plus 1 minus 1 all over 1 plus x. Everything, the whole thing is going to be raised to the number 2 as a power, which equals 3. Okay. So it's clear I'm going to divide this one into two terms. This one is clearly is number 1 because we have the same number in numerator as the same denominator. Okay. So I get x squared here plus 1 minus 1 over 1 plus x, all is raised to the number 2 as a power, which equals 3. So let's expand this one out to see what's going to be. Okay, so we get x squared here plus this one is going to give us number 1 minus 2 times all over 1 plus x plus the last term, which is 1 over 1 plus x quadratic square, which equals number 3. Let's use a nice trick here. Let's add number 1 here. This one becomes number 2 because I'm adding number 1, which equals 4. Now let's make the common denominator here. So I get x squared here. This one becomes 2 plus 2x minus 2 all over 1 plus x plus the last term, which is 1 over 1 plus x quadratic square, which equals number 4. Okay, so it's clearly this number 2 will be cancelled out with this minus 2. I will be left with the following. I get x squared, which equals 2 times is multiplied by x all over 1 plus x plus the last term, which is 1 over 1 plus x quadratic square. Everything equals number 4. Okay, like this. Now if you take a look at this expression, it's clearly is going to be a quadratic binomial. Okay, so this one equivalent to x plus 1 over 1 plus x, all is raised to the number 2 as a power, which equals 2 square. Okay, so I have ended with this nice expression here. Now let's get rid of this one and continue solving this equation. I simply ended with this nice expression. I'm going to take the square root on both sides. I will have two following solutions. I get the first solution, I get x plus 1 over 1 plus x, which equals number 2. Or the other one, we get x plus 1 over 1 plus x, which equals minus 2. Okay, so I'm going to go through each one. So by going through first one, so I'm simply going to cross multiplication. I will have x squared plus x plus number 1 all over 1 plus x, which equals 2. Okay, also I'm going to multiply both sides by 1 plus x. I will have the following. I will have 1 plus x like this, taking this 1 plus x like this. So I'm simply going to move over those terms to the left. I will have the following. I get x squared plus this x minus, I get minus 2x plus x, which is minus x, plus number 1 minus 2, which is I get minus number 1, which equals 0. Okay, going to calculate the discriminant of this one. Delta, I get delta equals 1 minus 4 times minus 1, which equals 5. So I will have the first solution, x 1 equals 1 plus square root of 5 all over 2. The second solution, I get x2 equals 1 minus square root of 5 over 2. Okay, so we get the two solutions in real numbers. So I get the second equation, which is x plus 1 over 1 plus x, which equals minus 2. Okay, so I'm simply going to make a simplification here, crossing the multiplication. First of all, I'm going to take the 1 plus x as a common factor here for the left side. So I will have x squared plus x plus number 1. Also, I'm going to take, crossing the multiplication to the other side, I get minus 2 minus 2x. Taking everything to the left side, I will have the reduced expression, which is x squared plus x plus 3x, x plus 2x, I get 3x. Number 1 plus number 2, after taking that to the left, I get plus 3, which equals 0. Okay, I simply have ended with this nice equation. So I'm going to calculate the discriminant of this one. I will get delta, which equals 9 minus 4 is multiplied by 3, which equals minus 3. This equation is not going to accept the solution in real numbers, which means this equation is going to accept the equation in the complex number. So I'm going to replace minus 1 with I. I get 3i squared. So I will have, let's change the form of this equation to make sure we are working on the complex analysis. Let's put this one as z. Okay, so I get z1, which equals minus 3 plus square root of this one, which is I square root of 3 all over number 2. The second solution, I get z2, which equals minus 3 minus I square root of 3 all over 2, like this. Okay, so I'm going to transfer this one to the Euler formula. It's more simple by using the cosine and sine here. So I get z1. I'm going to take minus square root of 3 out of these things here. I get minus square root of 3 factor square root of 3 over 2 minus I half. Okay, it's clearly this one is going to give us minus square root of 3. Replacing square root of 3 over 2, square root of 3 over 2, which is cosine of pi over 6. Get cosine of pi over 6 minus I of sine of pi over 6. Since we get cosine is an even function, I'm going to take minus sine inside, because as I have nothing, because I'm taking the minus sine inside of the cosine, doesn't affect this value of cosine. So also I'm going to take this minus sine inside of this one, because we have the sine is a odd function. So it's clearly minus square root of 3. It's clearly is going to give us minus square root of 3 is multiplied by e to the minus I pi over 6. Okay. So the second solution, I will have almost the same. So I'm taking also, this time I'm going to take minus square root of 3 factor square root of 3 over 2. In this time I have the plus sign between sine and cosine. I is multiplied by 1 over 2. It's clearly is going to give us minus square root of 3 of cosine of pi over 6 plus I of sine of pi over 6, which equals minus square root of 3 is multiplied by e to the I pi over 6. Okay, so I have ended with these nice solutions as a complex numbers. I have ended solving this equation. By the way, don't forget to hit the subscribe button and support our channel, and thank you for watching. I will see you in the next video. Bye.